Hello and welcome to another video on YouTube channel of tutorialspedia.com. During the digital transformation journey in any organization, APIs play a very pivotal and important role. APIs are everywhere when it comes to the integration of heterogeneous systems and applications, and we see APIs at the experience level, at process level, as well as at the system level. When implementing or when designing the APIs, it's very important to make sure that we design and develop our APIs in such a way that the APIs are not making a bottleneck. Rather, APIs are helping us in a very optimal manner with the performance optimized APIs. There are different strategies and methodologies which are followed during the journey of API design and development, which we can consider to make sure that our APIs are efficient and they are having a good throughput and a good response time. In this video, we will be talking about 5 practical approaches that you can consider for APIs to make sure that you have robust and performance optimized APIs. The first and foremost important technique that is often helpful to achieve a better latency, a reduced latency, and efficient APIs is caching. There are different scenarios where you can consider caching, and most important aspect of caching is that you reduce the overall traffic that is going to the backend, and you are entertaining the client API calls directly from the in-memory cache that you have built. As an example, let's suppose that you have a scenario where you have an API which is returning city codes for different cities in a particular country. We know that the city codes of the country within a country are not something which is changing quite often. So this is a primary candidate example of a scenario where you can think of caching. So basically you build a cache, you populate the cache, and then whenever there is a client request coming for that particular API, instead of going back into the database, opening a separate connection with database, and depending all upon the network as well as database performance, you totally rely on the memory and you have everything already pre-populated in memory, and you return back the response. This highly increases the throughput, and specifically in the cases where you have a very high number of flux coming in for a particular API traffic, then this type of approach really helps. The second approach, a practical approach that you can think to improve the performance of your API is to switch from synchronous to asynchronous model. As we all know that in case of a synchronous API, when a client makes a call, client waits for the response. So whenever there is a call, it goes to the server, and then whatever processing server is going to perform, and no matter how many number of backend calls it's going to make, client will be still waiting for a response in the same thread. So in the normal scenarios, whenever we don't have very heavy data getting processed, or we have a very little call going to the backend, in that case a synchronous mode of communication makes sense. But there are certain scenarios where we have to switch to asynchronous approach, where a client makes a request and then gets back a success response immediately, but there is certain level of processing that is going to happen behind the scene in the backend independently. So example can be that let's suppose an order processing system is there where a client creates wants to create an order. So client makes a request on a certain endpoint, and then the data goes to the backend system, and maybe we have Salesforce system, we have CRM system, and we have multiple other systems where a certain update is required. So in this scenario, it doesn't make sense that we do all these things in a synchronous manner and then respond back. Rather, a proper approach will be that we do the delegation, and in this way we just send back a response to the client with the 202 accepted response code, and client will know that his request has been accepted but not processed. So later in the backend systems, be it a CRM systems or any other system, everything is going to happen behind the scene, and once all of these processing levels have completed their jobs, then we can think of an event driven architecture, and we can return back an event, and that event is going to tell that original client that the processing has been completed successfully, or with a failure, whatever approach we're going to follow. So this type of approach really helps us to do the delegation of responsibilities, as well as it improves the performance because client doesn't have to wait for an indefinite period of time. Another popular approach that is used for optimizing the API's performance is payload compression. There are many scenarios or many type of APIs where we have a very large size of payload, and whenever the size of payload increases, so is the network traffic. So when network traffic increases, it puts extra overhead on the bandwidth that we have available, and this result in a performance degradation in most of the cases. So ideal scenario or ideal approach is that we should have very smaller payload coming in form of request or response, but also we can apply compression logic. So using gzip or any other compression technique, whenever data that is being returned as a response, or even when the request data is being sent, if it's compressed properly, then its size is significantly reduced, and in that way speed of the API is also improved, and we see a better response time and a greater throughput. Another popular approach is load balancing. Whenever we have some API implemented, we have options to do the implementation and subsequently deployment on multiple servers with the different type of specs, and also we can do the horizontal and vertical scaling in this way. And when we have a load balancer on top of that, which can be an application load balancer or even a network load balancer, in that way we can improve the performance because no single server is going to be overloaded, and different algorithms are used by these load balancers, like round robin, weighted round robin, or even some other types of more important and more proper load balancing algorithms, which can really help you to improve the performance as well as to achieve the fault tolerance. We can have multiple backend servers working either as the peers with the active role, or we can go with the fault tolerant mechanism where certain server is going to be considered as primary server, and then there will be secondary server. So in this master slave approach, we can have same API implemented and deployed in multiple servers, and then we can achieve the balancing, high availability as well as load balancing using these type of techniques. The last but not least, a very popular approach and a very important step is connection pooling. Whenever we see overall time that it's taken by any API, we see that the time it takes to establish the connections with the backend or with the databases, with the opening and closing of those connections, that takes a lot of time. And if we go with an approach where we create a pool of connections and then we reuse those connections, this greatly reduces this overhead of establishing the connections each time a request is made, and by reusing the connection pool we can significantly improve the performance. As an example, let's suppose that we have an API which is going to connect with Oracle database. So every time, if we don't use connection pooling, so every time there will be a call to that API, then it's going to open a new connection with that database, and then once that call has been completed, it's going to close the connection. So opening and closing the connection behind the scene has many steps internally, so that's always an extra overhead. It's time consuming, as well as it is causing load on our servers as well. So if we use connection pooling, that can greatly help us, specifically when we have time critical applications where we have time as a very critical parameter, and we want to make sure that we provide a faster response in real time, then connection pooling can greatly help us. So these were the 5 popular approaches that you can think of to optimize your APIs. Although there are many other methods as well that you can consider, like you can achieve better throughput through the pagination, where you make sure that you don't return all of the data in a single call. Rather, you have the option of offsets and page numbers. So that's another way that you can use to improve the performance of your APIs. And there are tons of other methods as well, but these were the 5 most important steps or options that you need to consider when you are going to design and implement your APIs. So that's it from this video. I hope this information will be useful. If you want to know more about APIs, API management, and integration in general, you can visit my website tutorialspedia.com, where you will find plenty of such interesting tutorials, as well as you can subscribe to this channel, Tutorialspedia YouTube channel. And here also you will find quite many useful videos regarding integrations, APIs, and in general other similar technical areas. If you like this video, don't forget to subscribe to the channel, as more videos like this will be uploaded in this channel in future. Thank you very much.